In the last video of this section, we're going to be talking about composite functions. Composite function is another way we can combine functions. Often, we come across situations where one quantity is a function of a second quantity that depends on a third quantity. For example, the cost of advertisement of a TV show may be a function of Nielsen rating. So that's a function of the Nielsen rating. However, the Nielsen rating is also a function. It's a function of how many people watch the show. So, number of people watching the show. So it turns out that the cost of advertisement is actually a function that depends on another function that depends on the number of people that watch the show. So composition of function f with g is denoted by f, a little circle in the middle, g, and it's defined by the equation f of g of x is equal to f when the argument is g of x. The domain of the composite function is going to depend on the domain of g and the domain of f when the argument is g of x. Example, f of x is 3x minus 4 and g of x is x squared minus 6 minus 1. Create f of g of x. Well, by definition, this is the function f when the argument is g of x. I'm going to show here with my boxes here the function f of sum of something is the same as 3 times this something minus 4. So if that something is f of x, then I'm going to do 3 times x minus 4. But if this something is g of x, then I'm going to multiply 3 times g of x. Well, g of x is x squared plus 6 minus 1. So the function f is going to look like f of g of x, or composition of f of g of x is going to look like 3 times the function g. And the function g is x squared plus 6x minus 1 minus 4. And I'm almost done. We just need to simplify this expression, combine the like terms. That's 3x squared plus 18x minus 3 minus 4, it's minus 7. So it's minus 3 from the beginning and then minus 4 at the end, and minus 3 and minus 4 combined to negative 7. And that's my answer. Since the domain of g of x is Oreo numbers and the domain of f when g is argument, we receive a quadratic function. The domain here is going to be all numbers from negative infinity to positive infinity. I'm sorry. G of x. G of x combined to f of x. So by definition, I have to consider the function g when the argument is f of x. Well, let's look how g of x look like. G when the argument is something is going to be equal to this something squared plus 6 times this something minus 1. Similarly, if it was g of x, we have x squared plus 6 times x minus 1. Well, now the argument is f of x. So g of x is going to be f of x squared plus 6 times f of x minus 1. That means g of f of x is going to be f of x squared. Well, f of x is 3x minus 4, so 3x minus 4 squared plus 6 times f of x, which is 3x minus 4 minus 1. I'm gonna squeeze that a little bit. To be able to calculate g of f of x. Now 3x minus 4 squared is 3x minus 4 times 3x minus 4. So 3x times 3x is 9x squared. 3x times negative 4 is negative 12x. Negative 4 times 3x is negative 12x. And negative 4 times negative 4 is 16. So just 3x squared minus 4 is going to be 9x squared minus 24x plus 16. So 9x squared minus 24x plus 16. And then I'm going to distribute the 6 times 3 is 18x minus 18x. And 6 times negative 4 is positive 24 minus 1. And finally, g of f of x upon simplification is going to be 9x squared minus 24 minus 18. That's 42 minus 42x. And then wait a minute, I have a mistake here. That's a positive 18. I have a mistake here. The function f was with the plus sign and I used the minus sign, so I'm going to correct that. So that was a plus sign here. So 6 times 3 is positive 18 and 6 times 4 is negative 24. I'm glad I got myself. So negative 24 plus 18, that's going to be negative 6x. And then 16 minus 24, that's negative 8, minus 1 is negative 9. So f of x, f of g of f of x is going to be 9x squared minus 6x minus 9. A little bit rearrangement here. Okay, what about the domain? Well, it looks like we didn't do anything to this linear equation and quadratic equation, so the original domain was all real numbers, so we keep having domain of all real numbers. I still don't like that. Okay, we'll continue with the next example. Okay, finally I like it. F of g of negative 2. So, similar question, but here we need to evaluate. What do we need to evaluate? We want to know what is f when the argument is g of negative 2. So we can do all the plug-in the way we did in the previous example with the x's, but we can also evaluate what is g of negative 2. And the function g was, I'm looking at here, x squared plus 6x minus 1. So I'm gonna go negative 2 squared plus 6 times negative 2 minus 1. So let's evaluate that. Well, negative 2 squared is 4, and 6 times negative 2 is negative 12, minus 1, this is negative 9. Negative 9. So pretty much we need to replace this negative 9 at the place of g of negative 2. At the place of g of negative 2. So we actually need to calculate what is f of negative 9 versus that. So what is f? F is 3x minus 4. Well, that means 3 times x, which is negative 9 in my case, minus 4. So 3 times negative 9 is negative 27 minus 4. Altogether, that's negative 31. So it turns out that f of g of negative 2 is equal to negative 31. Next example, example 5. Similar example with different functions. F of g. So f of g is going to be f when the argument is g of x. Well, f of box looks like twice this box minus 3. And I have to put in this box the g of x. So f of g of x is going to be twice g of x is square root of x plus 3. So twice square root of x plus 3 minus 3. Oh, I cannot simplify anything further, so that's going to be my final answer. Let's look at the domain. Well, the domain only concerns the function g, because the function g wouldn't exist if x plus 4 is negative number. X plus 3 is negative number, so we want x plus 3 to be greater than 0. So x needs to be greater than negative 3 or equal to negative 3. So the domain would be the lowest possible value is negative 3, and we keep going to infinity. G of f of x. G of box looks like square root of box plus 3. And we're going to put in this box f of x. So g of f of x is going to be square root. F of x is 2x minus 3. And we're going to add a 3. Well, negative 3 and 3 cancel, so g of f of x is going to be square root of 2x. Notice that we never used the function g in this problem in respect of x. We used it in respect of f of x. So the domain is going to depend on 2x being positive number or 0 number. So the domain would be all numbers that start from 0 and keep going to infinity, because x needs to be greater than or equal to 0, this to be true. And to calculate f of g of 1, on the place of f, I can go in the place of f of g of x to plug in 1. That's going to be too many calculations at the same place. Instead, I can simply go, okay, let me calculate what is g of 1 first. And function g is square root of x plus 3, so 1 plus 3, which that's square root of 4, or g of 1 turns out to be 2. So to calculate f of g of 1, I need to go f of g of 1. I need to calculate f of g of 1. Well, g of 1 is 2, so I need to calculate what is f of 2. And the function f is 2 times x minus 3, and instead of x I need to put my value for x, which is 2, and that's 4 minus 3, or the answer is 1. And the last example from this section is going to be combination between g and f at 0. Again, it's convenient to calculate what is f of 0 first, because that's g when the argument is f of 0. And f of 0 is, the function f was 2x minus 3, and instead of x I'm going to put 0. So that's 0 minus 3, or negative 3. Now I need to go to calculate g of f of 0. I need to calculate what is g at negative 3. And g was square root of x plus 3. So instead of x we're going to put the x value, which is negative 3. Or it turns out that g of negative 3 is going to be square root of 0, which is 0. And that's my final answer. And with this I'm concluding the video.